I've been in IBM for 35 years, and if I think about it, I've been in the industry for about 40, and it's been a crazy, crazy time. As a matter of fact, between my father-in-law, my late father-in-law, my wife and I, we've been in IBM 79 years. And that's such a long period of time, and I've seen so many changes. When I think about from the power of computers, the size of the computing elements, the amount of storage, all of that has changed so radically. But the funny thing is I look back, it's the actual particulars change quite a bit, but the only thing that really doesn't change is I know it sounds silly, but is change itself. Things are always changing. And one of the things that I enjoy is that every couple of years somebody says, this is the biggest change we've ever faced. And I kind of go, nah, it's always been the biggest change we've ever. And the future is always mysterious. And only when you look back, you think, oh, well, that wasn't so hard. And I think we're in one of those changes now. We're always in one of those changes. For my company, the biggest thing is that IBM used to be mostly a hardware company, and now we're very much services and software and hardware. The big change there is the move towards what we call cognitive computing. Those computing that learns, as well as, it's not just programmed. And that's pretty fundamental. For me personally, the company has had to reinvent itself. I've had to reinvent it myself too. I spent the first 33 years of my life working on chips, and I did the software that was used to design chips. Really cool things like video games and big processors and specialty chips for toys, anything. And as the company changed, I had to find something that used those talents somewhere else. And so I was really very lucky and very pleased to be able to find that IBM is going into Internet of Things, which is all about little chips talking to the cloud computing. So it's been like a perfect mix for me so far. So when I kind of look back, a lot of my career, I really like making things, and my career has been very fun because I've gotten a chance to make things. I'm at this conference, the QED conference here that was put on by CROZ, and the theme this year is about failure. And when I think about that, some of the funniest, best things that I've made have been by mistake. One of my favorite patents was I was working on a program with my friend, Loon, that was used for changing technologies, shapes in one technology to another. And I was writing on the blackboard, I was writing on a whiteboard a formula, and I got the formula wrong. And I went, oh, and I started to erase it. And I kind of looked at it and I went, hey, wait a minute. And so the best invention, I think the most valuable invention I ever made, saved hundreds of millions of dollars for the company, was a math error that I made on a board. And that was, turned out to be a very good patent, and we used it for years and years and years. So it's funny where those great inventions come from. Another invention, I remember working on one of our big, fastest computers. It was going to be one of the first computers in the world to go over a billion cycles per second. And I got asked to do something that was just impossible to do in the amount of time. So I kind of faked it. I sort of said, program goes here. I wrote some code, and it sort of did some function. And it turned out that that's what they used for about 10 years. They never figured out that it was a fake. But it wasn't a fake, but it was kind of a hack, as we say, something that I did quickly. So sometimes the best inventions are when you don't have a choice, you don't have a long time to think, you have to think real quick. One of the things I'm finding as I am more senior now, I look back and try to figure out, sometimes I get to talk to a bunch of young IBM people or high school or college kids, and I remember how boring that was when somebody was up there going, when I was your age, and I'm like, oh man, I'm that old guy now, what do I tell them? And I look back, and the thing that really stuck with me is that it was most important to play. And I don't mean like go play football, I mean like have a playful aspect of your work. And I know that sounds maybe a little strange, but when I think back to the times I was most creative and the most productive and the most happy is when I was able to kind of play with things, mess with them. And by play, I mean, first of all, not take it too seriously. I mean, there were times that I really it was very serious, right? The only way to handle it was to kind of laugh about it, But also play, when you think about how a kid plays, she or he is not worried so much about what's going to happen, not worried who's watching, not worried who's going to take their idea. They just do it. If they make a mistake, yay, that's pretty cool. And I found that the times that I was able to do that, I was more resilient and more creative. And the times where I forgot, because there were many times I forgot. It sounds really easy to, it's one of these things you have to keep reminding yourself. But when I'd get really serious and like, oh, I can't fail, that's when you usually fail the most, So I've learned that. And what's interesting is that it's not just me. I kind of look around, and if you think about my senior peers, a lot of them have this kind of playful spirit. They break the rules, they joke around. If you think back in whatever you do, out there in TV land, think of the people who kind of take it easy a little bit more and are a little bit looser. You might find that, if you can embrace some of that, you might find it very useful. So what's interesting about, my thing on play, my thing on chips, they're coming together for me in an interesting way is, I think the world is going to be changed by cognitive computing. I worked on the early Watson chips and that whole Watson technology of machines that kind of learn, there's an element, I know this sounds a little strange, there's an element of play. The way that a machine learns is by learning from mistakes. It tries something, says, hey, did that work? Okay, that worked. Hey, tries something, didn't work? No, okay. And you just keep learning, just like a little kid learns, like you learn through play. So when you bring that into the same realm as Internet of Things, I look at it as our job to actually give those cognitive, I don't like the word artificial intelligence, because it's not artificial and it's not really intelligent. It's a reasoning, learning kind of process. It's very prescribed. But when I think about putting IoT with that, it's like you're giving arms and legs and eyes and ears, even nose. We've got some people in our Almaden lab that are working on a nose for Watson. And so when you start to be able to put those kind of physical interfaces onto a cognitive process, you can learn about the world, you can change the world, and I think it's going to be pretty amazing. The most fundamental, the stuff that we're working on now is I don't want to say it's the easy part, but it's the first part, and that is making it much easier for people to interact with machines and processes. And you want something that works with you, that learns from you, that becomes more personalized as you use it. If you think about what's a good, if you go into an airport bathroom and you're trying to figure out where to put your hand for the paper towel dispenser, that's the opposite of cognitive IoT. You want something that learns, like your car would learn your preferences, learn your destinations, and help you get where you're going with less hassle. It's interesting, when you think about now, when you buy something, a building, a car, an appliance, from the day you get it, it starts to go downhill. Either it's level or it goes down. Imagine if the thing could start to learn and, in some ways actually get better with experience, just like a person does up to a point, right? And so that's the thing that's really exciting. So, making it so that machines like cars, like appliances, like toys, like industrial products, like robots. I've just been working on robots that actually understand speech, understand spoken speech in different languages, understand written speech, and not just the words, but understand what I'm trying to do, even understand jokes. I mean, that's what Watson is. It's pretty fun to mix those technologies. So, this is an amazing time to be in technology. I said a couple of minutes ago that it's always changing, but I do have to say that it's changing faster now than it ever has. If I were starting again, like if I were a kid in school and I was interested in this, the really nice thing about technology right now is it's very accessible. There's open source software available online. You can go on the web. You can get open source courseware. You can learn about this stuff, and you can try it. I think if I had advice, if I could get a time machine and talk to myself, 40 years ago, I would say just start trying stuff. It's not a spectator sport. You have to really get your hands in there and make some stuff. Even make a few mistakes. At least if you're making a mistake, you're making something that's creative. So go try some stuff. It's the technology. One thing is that's absolutely certain is the technology that you learn this week is not going to be the same technology you need 3 weeks later. So your ability to take something, decide whether it's useful for you, use it, and then take the new thing and put it in. Just learn to be agile, learn to be resilient, learn to learn, and learn to play.